Hello everyone, welcome back to the course. In today's lecture, we'll be learning about how JavaScript runs the code. Let's dive into one of the most fundamental concepts of JavaScript, the execution context. You will be learning about how JavaScript runs the code, what exactly is the execution context, what is this that a lot of people are afraid about, types of execution context, and the call stack. Think of execution context like entering a room. Even before the first piece of code runs, JavaScript has prepared a room for it, and inside that room, all the code runs. So it's an environment in which your code runs. That environment defines what are the variables and functions you have access to, what this refers to. Every execution context has two different phases. The first is the creation phase, or also called as the memory allocation phase, in which all the variables and functions are allotted space and memory, and the functions are hoisted in full. In the memory allocation phase, memory is assigned to functions and variables. Variables are initialized with undefined, and the full functions are hoisted. That means the whole thing is stored for execution. In the execution phase, the code is run line by line, and the variables are given actual values. When a function gets invoked, then a new context is created. You might have heard that JavaScript is an interpreted language. To be more precise, it's a just-in-time compiled. This two-phase process of execution is called a just-in-time compilation. This creates a few different behaviors that we'll look at later on. We have two different execution contexts, and each have their own memory allocation phase and the execution phase. First is the global execution context. Even before JavaScript engine runs the first line, it sets up a global execution context. It sets up the global object, all the variables that we have defined in the global scope, all the functions that we have defined in the global scope. In case of browser, the global object that it sets up is the window object that has a lot of different functions like the alert function, set timeout, set interval, the console.log, and also any functions and variables that are declared in the global scope are also set up in the global execution context. Then we have the function execution context. Anytime a function is being run, any local variables and functions that are inside that function, it's like a smaller room inside the global execution context. Let's look at these contexts with an example. So here I have an example on the left hand side. We have declared var a, const c, and a function in the global context. Whenever we run the code, it sets up the global execution context. Also, this variable, this is a special variable that points to what is running currently. In the global execution context, this refers to the global object. In browsers, it would be the window object, and in Node.js, it would be a global object. So going by this example, in the global execution context, first that context is created, memory for this variable a, const c, and this whole function programming that is defined in the global scope is being created. That is the memory allocation phase. And then when it runs line by line, a gets a value of 20, c gets a value of js, and then we execute this programming function. Also, since we are in the global scope right now, this is bound to the global object. And once we execute this programming function, now the next stage begins. Now, whenever we call a function, a new execution context gets created that is called the function execution context. Let's look at that next. The function execution context has an own sets of memory. Same thing happens. First the memory allocation phase takes place, then the actual execution phase takes place. So this function execution context goes on top of the global execution context. So it's like a stack. We can also access the outer scope through a reference to the parent. So the parent was the global execution context. So all the variables that are in the global execution context are also available inside this function through reference to its parent. Whenever a new context gets created, this also gets bound to something. In our case, this is still bound to the global object since this depends on how we are calling the function. We will look at this in much more detail in a later lecture. Just right now understand that whenever we call a function, a new execution context gets created, a new this also gets created, and that depends on how we are calling the function. If you are directly calling the function, without any method associated to it, then this refers to the global object. We will look at this binding in much more detail in a later lecture, so don't be worried about that. Right now, what you have to know is whenever we are calling a function, a new set of context gets created. And this is also bound to something new. but in our case, it's still the global object. When we execute this function, you can see we have a variable language over here and a function feature over here. The memory allocation for both of them will take place. Memory allocation for language and memory allocation for the function feature takes place in the memory allocation phase, and then we go line by line. Language gets the value and the function feature gets called. And now when this function feature is called, then again a new context will get created. Let's look at the function feature now. Again the same thing happens, rinse and repeat, memory allocation, execution. And this is bound to something. In our case, global object. And when we console.log, language is type. So language was JavaScript and is type whatever we defined, object oriented. So JavaScript is object oriented. That is what we'll get as output. That means every time we are calling a new function, a new context is created, and these two steps happen for every context that is created. Now let's look at what is call stack. Call stack is a structure that keeps track of what function is being called, and it's a last in first out. So whatever function we are calling gets moved to the call stack, then gets executed. Whenever the function finishes execution, it gets popped out of the call stack. Every function call happens on top of the global execution context. So each function call itself is like a box. That box has a set of memory allocated to it. The child function has access to the parent's function. In our case, in this example case, we have the global execution context. Function 1 is running on top of that, and function 2 is running on top of that. So function 2 will have access to all the functions and variables from function 1 as well as the global execution context through scope chaining. Let's look at an example, the same example. In this case, when we first ran our code, a global execution context gets created. Then when we call the function programming, this gets popped into the call stack. That means that a new execution context gets created. This gets popped into the call stack, and now the function execution takes place. Since the function execution is taking place now, same memory allocation execution. Now when we get to this line number 11, feature, again a new function is being called. That means this feature function gets moved on top of the call stack, and now the feature function gets executed. And this feature function has access to the variables of programming function as well. So this language is coming from the function programming, and type is local to it. And when execution of this function finishes, then that function gets popped out of the call stack. That means when we get out of the call stack, go back to where we called this feature function from. So from programming, we call the feature function. So at line number 11 goes back here. This is also the last line of the function programming. So that also gets moved out of the call stack. Then we go back to the global execution context. So after line number 14. At line number 14, all the code has been finished executing. That means it also goes back. The global execution context also gets removed from the call stack. Now the call stack is empty and the code has finished execution. This is the function of call stack. So it keeps track of what functions is being called, and it moves the functions on top of each other according to how they are being called. Let's look at another example. We have function A, which is calling B, function B, which is calling C, function C, which is logging out hello, function D, which is logging out just me. And then we have the execution of D and A. So at the start of the execution, the call stack is empty. A global execution context gets created. All the memory for A, B, C, D, all the memory for all these functions get created inside the global execution context. Then when we run this, when we go to line number 13, since we have called this D function, this gets moved to the call stack. Now when we see D, the console.log just me executes. At line number 12, the execution of D completes. D gets popped out of the call stack. Again, we move back to the global execution context. We have A at line number 14 gets moved to the call stack, and then A executes. Inside A, B executes. B gets moved to the call stack. Inside B, C executes, moved to the call stack. And after the execution of C, when we reach line number 9, C gets popped out of the call stack. Again, we go back to from where we call the function C, and then B also finishes execution, gets popped out of the call stack. A also finishes execution, gets popped out of the call stack. Now we are at the end of the program and the call stack is now empty. So all the code has run and the call stack has become empty. This is how code is run in JavaScript, and the call stack keeps in track of what execution is happening at what point of time. Here are the key takeaways. All the code that we run, everything runs inside an execution context, either it be the global execution context or the function execution context. Each context has its two different phases, the memory allocation and the execution phase. This gets very important when we are talking about hoisting. The call stack controls how the function is executed. The global execution context is created just once when we actually start running the code. A function execution context is created each time we call a function. Understanding this will inevitably help you in understanding JavaScript in much more detail, the scope chaining, lexical scope, hoisting, and all the later things that we'll cover. This is the fundamental of how JavaScript runs the code. All right, see you in the next one.